Hi everyone, welcome back to Statistics and Data Analysis. Today we're going to talk about the regression analysis again, and we will continue from our previous lecture to further introduce regression. So first I will introduce one case study with ticket selling, and with that we want to have materials to introduce two important concepts: indicator variables and interaction among variables. After that, we will also talk about one problem called endogeneity. We don't need to spend too much time on it because it's just one simple rule for us to select variables. Okay, so let's start. Consider the following story. There's a theater who make hundreds of stage performances in the past 6 years. So we have those data. We know where and when we made the play, what kind of play is that, and what's the sales. So the owner hopes that statistics and data analysis may help her improve the ticket sales. So we want to find out what makes a show popular. Sometimes when we make a performance, there are a lot of audience, but sometimes some shows are just unpopular. So we want to know what kind of shows may get a lot of numbers of tickets sold. Okay? There can be a lot of potential factors. What's the time for us to make the play? Where is the play? Who are the actors and actresses? What's the drama type? What's the ticket price? And actually many more. Okay? So we want to somehow identify what may affect the numbers of tickets sold, so that if there is something we should not do, we should try to avoid it, or something like that. Therefore, we randomly selected 100 performances from the whole pool, and all these performances were made during weekends, so we don't need to worry about whether there is an issue between weekend and weekdays. Tickets were all publicly sold, so we don't need to worry about whether the theater sends some tickets to somebody for free. Okay. Tickets for all performances were sold through the same channels, so we don't need to worry about how these tickets were sold because they are basically the same. For each performance, the ticket prices remains the same throughout the selling season, so ticket variability and price variability is not an issue. Okay, so while we control all these situations, we want to ask what may affect the performance's sales. Of course, in this introductory video, we don't have too much time to talk about all the variables. So we will only focus on a small group of variables. But still with that, we want to know how may we help the theater to improve the sales performance. Okay? So in this video, in this set of video, we only have 6 variables. We only want to use these 6 variables to introduce our important ideas. So the first variable is year, which is the year in which the performance was made. Time is either morning, afternoon, or evening. We want to know whether the performance time has some impact. There's a variable called capacity. It's the number of seats in the theater hall that the show was made. Obviously, this can have some impact. Average price, the average of all the prices for that particular show. Because for each show, there may be 5 price classes or 6 price classes. Some tickets are priced high, some tickets are priced low. So this single number is the average of all the prices. It's not something that can describe all the prices, but at least it's some kind of representative. Sales quantity is the total number of tickets sold. In this example, obviously this is the dependent variable. And finally, sales duration is the difference between the performance day and the day that the theater announces that the performance is going to be made. Okay, so this is the length of the selling season, the number of days that the ticket is publicly sold. Okay, so that's sales duration. We did some labeling and scaling. Years are labeled as 1, 2, 3, 4, 5, 6. Okay, so even though today it is 2015, but we don't label years as 2012 or 2014. We label them as 1, 2, 3, 4, 5, 6 because this is just for educational purpose. And this 1 means the first year, 6 means the last year. Capacities and sales quantities, they have been scaled in the same proportion. So later you will see numbers mostly around 200. That does not mean the capacity and the sales tickets are just 200. They have been scaled in the same proportion. Okay? Okay, so this is the data. We can see that we have year, time, capacity, average price, sales quantity, and the sales duration. You can see that we have all kinds of different combinations. And for time, label is A or E or M, means afternoon, evening, and morning. Years are 1, 2, 3, 4, 5, 6. And we have capacity mostly around 200, sometimes a little bit larger, sometimes a little bit smaller. Average price is also somewhat different. Sometimes the theater tried to increase the price, and we want to see whether that has some negative impact or positive impact. Sales quantity is here. Obviously, it's not going to be larger than the capacity, and we have sales duration. Sometimes it's short, sometimes it's long. This is the second half of our data set, and if you have some free time, try to go through it. Okay, so eventually we want to do a regression analysis or any kind of statistical analysis, but still we need to start from descriptive statistics because that's the first place for us to get some insight or get some ideas about our data. And in many cases, that's going to decide the data, the statistical methods we need to use. Sometimes after you draw some figures or get some basic numbers, you will just stop because probably the problem is too straightforward and you don't need to do any study. You know what's the problem and how to act. Or sometimes you find out that you need to collect more data or clean out some data. Yeah, so descriptive statistics is the first step. For year, we find that okay, we have different numbers of performances in each year in our data set. So ideally, they probably should be somewhat uniform, or the numbers should not vary too much. But anyway, yeah, it's not perfect, but it seems to be okay. For time, it's somewhat uniform. So most of the shows were performed in the afternoon, but for the morning we still have 29. For the other 4 variables, we have these statistics because it's too hard to list all the numbers. Okay, so please take a look. An easier way is to just plot them. So this is a line chart for the number of performances in each year. We can see that in our data set, the first 2 years has the first peak, and then the smaller numbers, and then another peak. Of course, this does not really mean anything for the real situation because we only have 100 randomly drawn performances. So the true number of shows is actually larger than that. So yeah, just something to keep in mind. We have bar chart for time, and then we have histogram for the other 4 variables. We can see that for capacity, most of the theaters, the capacity is around 200, and within the class 150 to 200. Actually, if you look at the data more carefully, most of the shows were performed in one specific theater whose capacity is 200. Okay, and then average price. Most of the shows were priced around 500 to 800. but there are also some shows that are priced somewhat extremely higher. For sales quantity, it's some kind of normal curve. So most of the shows were getting sales quantity around 150 to 200. Sales duration, we can see two peaks. Some shows were planned much more in advance and has a long selling season. Some are not. Okay, so to construct a regression model, we first need to consider quantitative independent variables, because so far this is the only thing we can do. Okay, we haven't told you how to play with qualitative independent variables. In this problem, the dependent variable is the sales quantity. We want to know what may affect the sales quantity. And the independent variables, here we have capacity, average price, and year. So first, let's ignore sales duration for a while. We're going to talk about it at the end of today's lecture. And then we know that time, which may be morning or afternoon or evening, is qualitative. So let's ignore it for a while. There's one thing to be discussed. Year is a quantitative variable. Okay? Even though year only takes 6 different values. In this example, year is quantitative. Why? The difference between two values makes sense is the key for us to understand that year is a quantitative variable. So years are from 1 to 6, but when you think about, for example, 4 minus 2, or think about 5 minus 3, they both mean a difference of 2 years. And from first year to second year, our regression model will be able to measure the impact for 1 year passing by. And then from second year to the third year is also the same thing. And from the second year to the fourth year, the impact should be proportional, 2 times larger than from first year to the second year. Okay, because time in the time duration can be measured as a quantitative variable. One another reason for us to say that is because the values will keep increasing. So we are not just labeling some qualitative numbers with numbers. Okay, what we are really doing is indeed years is a quantitative variable. Let's take another example as a counterexample. If we have a variable called month, then we know we in many cases label them as 1, 2, 3, 4 up to 12. But even though they are numbers, we don't say month is a quantitative variable because the difference between 12 and 1 can be ambiguous. It may be 11 months or it may be 1 month. So if you have a data set in which the data has been collected for more than 1 year, and then month can be ambiguous. So month in that case would be treated as a qualitative variable. Okay, so now we have selected 4 variables and we want to focus on the regression model with them. So we should first get some scatter plots, right? Because we want to know whether we need to do any variable selection. That means does a variable has an impact. If a variable actually has no impact on the y variable, we probably should ignore it. Transformation, what is the variable's impact? We probably need to do some nonlinear stuff. Multicollinearity, we want to know whether 2 variables are highly correlated. If that's the case, we probably only need one of them. So the scatter plots are here. Capacity and sales obviously has some positive correlation, so we need that. Average price and the sales quantity, the impact is not so obvious. It seems to us that people tend to like mid value of average price. Year and the sales quantity, seems that we are having a downward trend. Yeah, so probably this is something to keep in mind. So if we have a lot of variables, probably we will keep average price aside for a while and focus on other variables because the relationship here is not clear. But here, because we only have 3 variables, we are going to try them anyway. We also want to check the relationship between independent variables. Basically, we don't see any strong patterns. Okay, so well, we tend to believe that they are not correlated with each other. So that's good. You may of course calculate the correlation coefficient. They are just not so big. Okay, so these variables seems to be good. They are worth a trial. So let's put them into a regression model. There is one issue. Some people would try to put them into a model one by one. So I want to do a regression model with sales quantity and capacity, or sales quantity with average price, and the sales quantity with year. If I really do that, I get 3 independent regression models. I can see that, oh, the first one seems to be okay. The second one and the third one are not so good, right? Even though the third one has a significant value, p-value. So I know year is reasonable, year should be used, but its R-square is so small. So if you do this, you can get some ideas about these variables, but that's not very useful. That's not very useful because whether a variable has some impact needs to be considered after you take away the impacts from other variables. Okay? For example, average price. Here we don't see it has any impact on sales quantity, but actually there are some. Even though that's not very significant, but there are some if we take away the impact of capacity and year. Okay? So the right thing to do is to put all the variables you are considering into your model together. Then our regression model would change a little bit to this one. So let's validate this model. So the first thing we find is that R-square is 57% and R-square adjusted is around 55%. Both are moderately fine, right? And then we have 3 p-values. They are 0, around 0, and even closer to 0. So capacity obviously has an impact. Year also have a very small p-value. So at 5% confidence significance level, year is significant. Average price, the impact is small. The impact is small, but still it's significantly not 0 if we take 10% as the significance level. Okay, so once you put all the 3 variables into one model directly, we can say they are all significant. They all have some impact. So do not try independent variables separately, try them together. Okay, now it's time to talk about the next problem. We know that time may also have some impact. However, it's qualitative, okay? Or more precisely, it's nominal. So even if we label it as numerical values, we cannot treat it as a quantitative variable. If we do that, it will be problematic. So for qualitative variable, what we want to do is to introduce something called indicator variables to somehow represent the values. So in the next video, we're going to tell you how to include a qualitative variable in our regression model. Thank you.